So what we're doing today is we are starting chapter 2, quadratic functions. Now the nice thing with, now that we've gotten out of chapter 1, is that all the rest of these chapters are going to have some kind of similarity to them. So the main focus of chapter 2 is going to be quadratics in different portions of quadratic functions. So we're not going to be jumping around. We're not going to be talking about a lot of different things. And specifically today, we're going to talk about transformations of these quadratic functions. We're going to talk about transformations again. And we know that A, H, and K do have an impact on the quadratic function. K, for instance, moved the function up or down. It was kind of nice. If there was plus 2, it moved it up 2. If it was minus 2, it moved it down 2. So K was kind of nice in that it was our vertical translation, our up or down, depending on what K is. K is positive, it goes up. If K is negative, it goes down. H was our horizontal translation. It was our left or right. And really, when we talked about this before, it's kind of the opposite of what we think, because if H has a negative value, it's going to look positive in the function. And when H is positive, it's going to look negative in the function. So we kind of had that sign switch. A had two main places, because if A has a value other than 1, a positive value other than 1, it's a vertical stretch. If A is greater than 1, and it was a vertical shrink if 0 is less than A is less than 1. Vertical stretch if A was greater than 1, vertical shrink if it's between 0. And we also said if A is negative, it is a reflection across the x-axis. And kind of those we talked about specifically. Now the first two here is horizontal vertical translation, our H and K. If the value of H is positive, it's going to shift it to the right. If the value of H is negative, it's going to shift it to the left. Horizontal left, right. Vertical up, down, our value of K. If K is positive, it's going to move it up. If K is negative, it's going to move it down. So I'm going to rewrite this function over here, g of x equals parentheses x plus 4 squared minus 1. H and K. Now the general form for this here, f of x is equal to a times, really we do have a value of b. B, I will put it in especially once we get to it, is our reflections across the y-axis and our horizontal stretch or shrink. Now looking at this here, do we have a value in place of a? There's no number in front of the parentheses. There's not even a sign in front of parentheses, so we don't have a vertical stretch or shrink or reflection in the x-axis. Do we have a value for K, sorry. Do we have a value for K? Yes. K's value is -1. Now the nice thing with K's is exactly what it looks like, since plus K plus -1 minus 1. That tells us that there. Now we also have a value for H. And H, the number for H would indeed be 4. Now, would it be positive 4 or negative 4? It would be negative. Because for us to get this to line up with the general form, the only way for us to get it to go from x minus h to x plus 4 is if that value of h is negative. So really what we're looking at is x minus negative 4, telling us that value of h is negative 4. Questions on this here? So the transformation, so the minus 4, we wouldn't put that it's minus 4 units. It would be what? Left 4 and down 1. And that's it. Now, we don't have to, especially on the homework, I'm not going to ask you to graph them, but if we were to graph this, now this here, it gave us the parent function, x squared. Now, we're saying that what we did to go from x squared to x plus 4 squared minus 1 is that we moved every point on this parent function here, left 4 and down 1. So at 0, 0, we go left 2, 3, 4 and down 1. This here would be our new point. From 1, negative 1, 1, we'd go left 1, 2, 3, 4 and down 1. From 1, 1, we'd go 1, 2, 3, 4 and down 1. From this point here, 2, 4, we'd go left 1, 2, 3, 4 and down 1. Same with our last one, 1, 2, 3, 4. And this here would be our new graph. We moved everything left 4 and down 1. Now those 5 points I picked were just kind of nice points on that graph, our original x squared. And again, the most part what we're doing for this here is just to get a good idea of what the graph looks like, and when we moved it, how it should look. Questions on this here? Are you ready for the next one? All right. I'm going to put that B in there because that B is our vertical or our horizontal stretch or shrink or reflection across the y-axis. Now at this point here, we don't have a value for B besides 1. There is no value there. So that means there is no reflection across the y-axis. There is no horizontal stretch or shrink. Is there a value in place of A? No, so there's no reflection across the y-axis. There is no vertical stretch or shrink. But we do have a value for K. Do we? Is there anything added to it? No. So K is not existent. How about H? There's a number in place of H, yes? It is 3. Now would that 3 be positive 3 or negative 3? It would be positive because we have x minus h, x minus 3. X's line up, minus line up, so h is 3. Any other transformations there? No, so it's telling us what we're moving it right 3. So if we were to look at the graph, this graph here, every point on it is going to what? Move 3 units to the right. So 1, 2, 3. That's all it's doing. So if we have a good idea what the parent function x squared looks like, we know what the new one looks like. It just moved it 3 units to the right. Questions on this here? So looking at this here again, A and B, we don't have a value. But do we have a value for K? And what's K's value? It is 2, but it would be -2. Do we have a value for H? The number would indeed be 2, but would it be +2 or -2? It would be +2 because x minus h, x minus 2. So it does line up, our signs line up, so h has to be +2. And that's it, because there is no number in place of B or A. So those are our only two transformations. Since h is +2, it tells us we're moving right 2, and the K value tells us we go down. Right 2 and down 2. And that's it. Questions on this here? Questions on anything we've done so far? Be ready for the next one. Well, just like the last one, we only really have values in place of h and k, yes? Now, k's value is 1, and it would specifically be +1. K, or h, sorry, I haven't flipped. H would be -5, yes. K is going to be +1, h is going to be -5, because for g of x, really what we're looking at is this x minus -5. Because x plus 5 would be our x minus -5, really showing us what the true value of h is, which is -5. And how would this move? It would be left 5 and up 1. That's it. Questions on this here? Do we feel good with these here? Yes? Because if we looked at this here, this would have been right 1 and up 2. Reflections. If A is negative, it's a reflection across the x-axis. If B is negative, it's a reflection across the y-axis. Now I call it B, and when I say B, I just mean it's negative. There's a negative sign in front of x inside parentheses. If the parentheses are not there, or we don't have them listed or written in, they aren't, that negative or that sign is not inside. Because if there's a negative in front of the x, but there is no parentheses, it's on the outside. We specifically have to have the parentheses written for it to be inside the function. Now this here, in the general form, if you notice, it just drops the parentheses because negative x squared and x squared end up being the same function. It reflects onto itself. And it does this because it is what we call an even function. It's symmetric to itself across the y-axis. But if the negative is outside the parentheses, there are no parentheses, it's across the x. If that negative is in front of the x inside the parentheses, it's going to be reflected across the y-axis. Vertical stretch or shrink, we've talked about this before. That A, if that value of A is greater than 1, it is a vertical stretch. If that value is between 0 and 1, It is a vertical shrink. And we felt pretty comfortable with those there. The one that's a little tricky is horizontal stretch or shrink. Now, horizontal stretch when A is between 0 and 1. Horizontal shrink when A is greater than 1. And we have to end up flipping it. And this is where it's coming into play and kind of us thinking through, because this here is talking about the value specifically written in the function itself. So if it tells us inside the parentheses we have 1/2 x being squared, 1/2 is between 0 and 1, and it's a horizontal stretch. But when we list it, we have to flip it, that 1 over that value. So it'd be a horizontal stretch of 2, even though 1/2's in the function. So this here is specifically looking at the value when it's in the function. Not so much what we're talking about, the stretch or shrink. Because if we take whatever that value is, flip it, and then look at it for stretch or shrink, it would be a horizontal stretch if b is greater than 1. Or shrink if 0 is less than b is less than 1. So if we're looking just at the value, it has this kind of flipped effect. Does that make sense? If we go on and flip it, we can think of it the same way we do vertical. We flip it. If it's greater than 1, it's a stretch. If it's between 0 and 1, it's a shrink. Well, let's look at some of these here. Now, if we look at this first one here, this first example, is there a value for k? No. Is there a value for h? No. Is there a value for b? Because b, what I call b, is specifically inside the parentheses. Do we have parentheses written? No. So do we have a value for b? No. What we do have, this negative 1/2 is taking the place of a, yes? So our a is negative 1/2. Now, a and b tell us two things. One, if there's a reflection, and two, if there's a stretch or shrink. Is a negative? Well, yes. That negative tells us specifically that there is a reflection across the x-axis. That's specifically what the negative tells us. That negative tells us specifically that there's a reflection across the x-axis. That's all the negative tells us. The 1/2 tells us if there's a vertical stretch or shrink. If it's greater than 1, it's a stretch. If it's between 0 and 1, it's a shrink. Now the question is 1/2 greater than 1 or between 0 and 1? Between 0 and 1, so it would be a vertical shrink of 1/2. That's it. So it's a reflection across the x-axis and a vertical shrink of 1/2. And that's it. That's the only transformations that we have. Are you ready for the next one? Now, the order in which we look at these and see our values for A, B, H, K really doesn't matter. So looking at this here, is there a value for A? No. I mean, there's 1, but that doesn't help us. How about H? No. Is there a value for K? Yes, and the value of K is 1, and it would be positive. Do we have a value for B? And we have a value B of 2. But really, what we're looking at, we have to flip it to 1/2. So here, because 1/2 is between 0 and 1, we have a horizontal shrink by a factor of 1/2. And if we looked at the general definition, and especially what they told us in the notes for that form, if it's called it A, I hate that he calls it A. If A is between 0 and 1, it's a stretch. If A is greater than 1, it's a shrink. So here, the A value would be 2. It's greater than 1, so it's a horizontal shrink. So this would indeed be a horizontal shrink of 1/2. Because we still use the 1/2. Even though the A value or the B value is 2, we look at the flip form, not the regular form. At this point, and again, for me, I just flip it and think of it as 1/2 for that horizontal shrink. The only other transformation we have is the +1, which would be and up 1. Because really, once we wrap our head around the flip with this horizontal stretch or shrink, everything else kind of falls in line. Questions on this here? We ready for the next one? So looking at this here, do we have a value for H or K? No, so that means it's not moving left or right or up or down. Do we have a value for B? No, because we would need parentheses. All it's telling me is that A is what? -3, yes? It's telling me two things. One, the negative is a reflection across the x-axis. And the 3 is a vertical stretch of 3. Because that negative and 3 are two different transformations. Questions on this here? Here we have two different transformations. We have a value for B and K, yes? Let's start with K. K would be what? -2. Now specifically, the number in place of B is 1/4. But the number we want to look at really is the reciprocal, the flip of it, which is 4. Since the value of B is 4, it does tell us that we have a horizontal stretch of 4. And the K tells us we are going down 2. Now with this here, 0, 0, it's kind of the funny spot because it's just going to go down 2. Now normally we would go over 1 up 1 for our next spots. That's the normal x squared. But for us to be able to go the distance 1 up, from here we can't go over 1. We've got to go over 4. Because if we plug 4 into x, 1/4 times 4 is going to give us 1. 1 squared is 1, minus 2 is negative 1. And we get this here. I got that right. I think so. 8, 10. Yep. So even though the number for b is 1/4, the number in the function is 1/4, we can see that it is stretching it horizontally. It's increasing faster horizontally. It's kind of funny it works that way, but that is how it works. Questions on these here? One-third x squared. Well, here, the only thing we have is a value b of 1/3, yes? But it would actually be a value of 3. Telling us that we have a horizontal what? Horizontal stretch of 3. Now, we won't have too many functions, or we really won't have any functions that will have horizontal stretch or shrink with a horizontal translation because they affect each other funny. There's a funny effect with those. I think we have 2 more. Yep. Here we only have 2 transformations. We have a value for a and h, yes? A would be 3 and h would be positive 1, yes? Now since a is 3, it's telling us that we have a vertical stretch of 3 and what? The positive 1 would be right 1. And that's it. Questions on this here? What would be the transformations for this last one? Up 2. Up 2, then what? Left 3. And a reflection across the x-axis, yes. And that's it. Now we will finish the note sheet tomorrow. This here I'm going to go on and give you the assignment. The only thing we really have left to do in the notes is to apply the transformations to a given function and talk about vertex form. Because the function this here, we are given the vertex. We're given the vertex of this equation. But that's it for today.